very fascinating one for the students, and that was an inspiring one also. So I am really grateful to you for accepting my request. And let me try to add our vice chancellor also. He too was wishing to interact with you for a moment.
Oh,
And
sure. I will just log in for a few minutes through the phone for the video, then I'll switch it off because
okay,
just.
let me check if he will be available with us, and we'll start your lecture at 11:30 because still the students are rushing in this hall.
Sure, sure.
So
The slides are visible, right? Just for
yeah,
checking.
yeah, yeah, yeah. Slides are very much visible.
Anita ma'am, I will just join through the phone just for the initial few minutes for the video because it's not recognizing. Then I'll switch it off and come back to this. Is that okay?
Okay, ma'am.
So, yeah, so do let me in. There will be another request from Shama. Yeah. So I just thought initially I just wanted the screen. Thank you very much. Yeah,
Yeah,
thank
thank you
you.
very much. I'll just do this for a few minutes and then switch to that.
Sure, ma'am.
Shall I start? Honorable VC sir. A very warm good morning to one and all present here. I, Dr. Roli Tiwari, welcome you all for being a part of this auspicious celebration of Festival of Science and Technology under Azadi Ka Amrit Mahotsav, Vigyan Sarvatra Pujyate, the Festival of School for All, organized by Pandit Ravi Shankar Shukla University, Raipur, Chhattisgarh. We are celebrating this festival of science for a week long. Today, in the third day of the program, we have two renowned speakers to grace us. Before introducing our speakers, I would like to humbly request Honorable Vice Chancellor of the University to bless us with his kind words. Honorable VC sir, over to you.
गुड मॉर्निंग टू ऑल ऑफ यू। आज़ादी का अमृत महोत्सव, इस महाउत्सव के अंतर्गत विज्ञान सर्वत्र पूज्यते को केंद्र बिंदु बनाकर आयोजित इस विज्ञान सप्ताह के तीसरे दिन हम अपने विदुषी डॉक्टर श्यामा एन को अभी सुनेंगे। आप स्पेस रिसर्च एंड एक्सप्लोरेशन पर अपना व्याख्यान देंगी। हमें खुशी है कि हम इस महोत्सव को बड़े गरिमामय ढंग से आयोजित कर रहे हैं। उद्घाटन समारोह में मुख्य अतिथि के रूप में महामहिम राज्यपाल और कुलाधिपति सुश्री अनुसुईया उइके जी पधारी थी, और आज हमारे बीच एक विदुषी वैज्ञानिक हमारे बच्चों को, हमारे शिक्षकों को, आम जनता को और हम सबको स्पेस रिसर्च पर अपना व्याख्यान देकर लाभान्वित करेंगे। हमें इस बात की सचमुच में बहुत प्रसन्नता है कि उनका सानिध्य हमें मिल रहा है। उनके ज्ञान का लाभ हमारे सभी विद्यार्थियों को प्राप्त होगा, हम सबको प्राप्त होगा। मैं पंडित रविशंकर शुक्ल विश्वविद्यालय की ओर से उनका स्वागत करता हूं, अभिनंदन करता हूं, और मैं आशा भी करता हूं, उनसे उम्मीदें हैं कि वे हमारे विश्वविद्यालय से इसी तरह जुड़े रहेंगे। उनका सानिध्य लाभ हमें मिलेगा, उनकी विशेषज्ञता का लाभ हमको मिलेगा, और इस कार्यक्रम के बाद भी हम चाहेंगे कि समय समय पर हमारे विद्यार्थियों को, हमारे शिक्षकों को, हम सबको स्पेस रिसर्च पर और वे जिस विषय पर चाहेंगे हमें अपने ज्ञान से लाभान्वित करते रहेंगे। पुनः मैं आपको सादर आमंत्रित करता हूं। धन्यवाद करता हूं। नमस्कार।
Thank you so much for your kind words, sir. Now, I would like to introduce our first speaker, Dr. Shyama N, to our listeners. She is a senior scientist in Space Science Division, ISRO, Bangalore. She has completed her PhD in physics from ISRO Satellite Center and University of Calicut between 2006 to 2011. Her topic for research was X-ray studies of the moon. She has also been felicitated with many awards. Few are EGV Young Scientist Travel Award in 2015, Chandrayaan-1 Payload Team Award in 2009, Lunar and Planetary Institute Career Development Award 2008, and many more. Her research areas are on the development of experiment and analytical method of the study, the composition in the solar system, area of expertise in X-ray, spectroscopy and instrumentation. She has more than 50 publications in international journals and several conferences proceedings and has served as a reviewer in many international journals, etc. She has guided 2 PhD students and several graduate and postgraduate students. Her topic is very interesting, and we hope that your lecture will definitely felicitate our students. With this kind note, I am inviting you to present your lecture now. Please.
अच्छा परिचय के लिए बहुत बहुत धन्यवाद. I will now share the screen and thank you.
Please.
Yeah, hope it is visible. So, namaste from Bangalore. I'll try to give an overview of space science, exploration, and what does it, what does it provide us with in actually exploring not just Earth, the planets, and the whole large universe. A basic fundamental question when we talk about space sciences, or for that matter, anything fundamental, is our quest. So the basic fundamental question is, how did all this come about? We are on planet Earth. We see many other planets in our solar system, and if you look at the sky, there are billions of stars, billions of galaxies. So we are in this tiny part of the universe, looking at these things, and from ages, as far as if you look at the quote from this Upanishad, as far as we can remember, the basic question of humanity is, where are we? How did all this begin? Where did we come from? What is it going to be in the future? And in between this, who am I? So when we start from this, let's look at our solar system first. As we know, this is how our solar system is today. There is a sun in the middle, the planets are going around it. Further out, you have a region called the Kuiper Belt, and even further away, you have a region called the Oort cloud, from where we believe the comets are coming. So you would have heard of comets that come at regular intervals, in intervals of, like the Halley's comet that comes around every 70 years or so. Then there are comets that just appear once in a while. So looking at how they move in the solar system, we can track back from where they are coming. And so we believe there is a region called the Oort cloud far away in the solar system. So remember, this is a structure that we have come up with by looking at the sky. Now, as I said, like, as far as we can remember, always humanity have asked this question, right? How did all this begin? So long ago, there were myths, stories, folk tales. In every culture, in every country, there are stories about how Earth formed, right? You would know some of our Indian stories. In every language, there are different stories. Then further, it's about in the 16th century that a rational theory for the Earth's origin was proposed by the French philosopher and mathematician René Descartes. He talked about Earth forming from a cloud of gas and dust. Then there was this passing star hypothesis by Buffon, he looked at around he thought of other objects that you see in the sky, how there are stars and far away in the universes, and thought that if these clouds of gas and dust has to come together and form a solid body, it needs a trigger. So he came up with what is called a passing star hypothesis, where a passing star would give you that trigger, gravitational trigger, which pushes objects closer. A modern theory that today we as we understand how the solar system began is from about Laplace, again in the 18th century, and that's called the nebular hypothesis. Even though this theory is as old as the 18th century, we keep refining it with what we observe now. So how do we actually go about finding answers to a particular problem? So to give an example, let's ask ourselves, how was the solar system formed? So any viable theory for the formation of the solar system must follow certain things. So it should be based on physical principles, because no, we have the basic physics here. So it should conserve energy, it should conserve momentum, the law of gravity, the law of motions. So whatever theory that we construct for the case of solar system, but this is true for any other research that we do, it should be based on the known physical laws. It should be able to explain all or at least most of the facts with reasonable accuracy. So for example, when you look at the solar system, all the planets are going around the sun in a sort of in a plane, right? There is nothing that goes in a polar orbit around the sun. So that's an observation. So when you make a theory, it should follow all these. Then you look at the planets. All the planets in the inner solar system are rocky objects, whereas if you go to the outermost regions of the solar system, like Jupiter or Saturn, they are ice giants. They're called ice giants because there's a lot of ice there, water ice, carbon dioxide ice, and it has a very thick atmosphere. We cannot see the surface. We cannot see the rocky surface of the planet. So there is a segregation there. And there is an asteroid belt in between Mars and Jupiter. So these are all observations that we have. So when you make a theory or a hypothesis, rather, about how this formed, you should be able to explain all of this. And not only that, we know today that it's not just Earth. There are many other planetary systems. Right? In fact, every star has at least one planet, or possibly many more. That's how we understand today. So these are called exoplanets. We have around more than 4,000 planets discovered in other systems. And we today know that this is actually a natural process of formation. For every star that forms, there should be planets around it. So therefore, when we make a theory about solar system formation, it should not just be a special case for ourselves, but it should apply to other planetary systems. Now, how do we go about finding the answers for these things? So the first thing is we observe, looking for clues, and then we guess and come up with some explanation. Then you test it and see if our guess explains everything or most of it, and try again. If it doesn't quite work, go back to step 2. So in the case, if you look at our solar system, you look for clues, as I said, that all the rocky planets are inside, all the very big planets are at the outer edges. You have the asteroid belt, all of them are going around the sun like a disk. So all these factors are the clues that we are looking at. And then we build the theory like this. So today we believe the solar system formed from a disk of cloud and gas around the sun, or the young sun, in the very early part of the formation of the star. The leftover material forms a disk around it, so it rotates along with it. And as the whole system cools down, there is momentum is transferred. And so you get clumps of matter here and there in this disk, and those form the planets. So we go about this again and again, iteratively. So you go back to step 1 if you find that something doesn't work, and we build a theory within the framework of the known laws of physics that will help us explain the past, or builds the past, explain what you see today, and then you should be able to predict the future, like what will happen to Earth, for example, in future. So we know that our sun is not going to stay like this forever, right? It will grow into a red giant phase, and by then it will be so big that Earth will be engulfed in it. So when we explain something like this, star formation and the planetary formation around it, it just gives you a complete picture of what's happening, what happened in the past, and what will happen in the future. How do we, so we said observe. Now, what to do about this? How do we do this? So we look at electromagnetic radiation. That is the main source, that is the measurement that we do to come up with many of these conclusions. So electromagnetic radiation is not just invisible. We have the ultraviolet, the infrared, X-rays, gamma rays, radio. So you would have studied in school and college the entire spectrum of electromagnetic radiation, which have different frequencies. They all, in the universe, many objects emit much of this radiation. So early on, when we were looking at it from ground, we see the visible light and in radio. But as you go up in space, for example, here is an X-ray image of a magnetar. A magnetar is a very, very high magnetic field neutron star, and you can see an image of in X-rays. And here is an image of a galaxy by the ultraviolet telescope on the AstroSat, India's astronomy observatory, and you see how the structure is. So image gives you a very beautiful picture and the structure that is present in there. So electromagnetic radiation is one of our main sources for measuring radiation from many of these objects, and using that to interpret what the object is, or how did it form, and how is it going to evolve, etc. Then there are particles. The universe is pervaded by charged particles, protons and electrons, for example, and the sun emits particles during active phases, like when there is a solar flare, which are energetic bursts, followed by, there will be charged particles also are emitted from the sun. They move very fast through interplanetary space, affect satellites. So these particles are another source of information. Then there are neutrals, like the neutrons, which don't have charge, but again, they are all results of nuclear reaction. So when you measure something like this from a particular source, we would be able to say what kind of source is this. For example, you look at the sun. The sun's corona, which we see during an eclipse, solar eclipse, is very, very hot. No, and so it emits in X-rays. Then you can say that, okay, since this is emitting in X-rays, it should be 1,000,000 degree Kelvin hot. So just by measuring many of these radiations, you can tell a lot about the source of emission, and that's how we learn about these different objects. Recently, gravitational waves is another very exciting topic that's been growing in the recent years, because as predicted by the general theory of relativity, these are ripples in space-time that now we actually can measure from exotic processes like mergers of black holes and neutron stars. Now, we have been looking at the sky, from the time of Galileo. Galileo started using the telescopes to look at the sky. He drew sketches of the moon. He looked at it every night and had gathered so much information. So we can do this from ground using telescopes. So these are some of the Indian observatories here. There is this GMRT near Pune, where you look at the sky using radio telescopes. In fact, it's a very large array of radio telescopes. That is state of the art. There is the Udaipur Solar Observatory shown here, which looks at the sun. There is a 3.6 meter telescope at Devasthal. This is the Kodaikanal Solar Observatory, which is more than 100 years old. And these are all at very beautiful places as well, and quiet places, because many of these observations we don't want disturbances or interferences from visible light pollution or radio interference. So most of these are built in very quiet locations. So these are all incredibly useful to have long observations of a particular object from ground, and still they are very widely used. And this is another beautiful picture of the Indian observatory called the Himalayan Chandra Telescope at Hanley. And you can see the very clear sky so beautifully visible at Hanley, because the the atmospheric condition is such that the sky looks extremely beautiful there. Now, so we said we have ground telescopes. Then why do we have to go to space? So that's because what we see on Earth, whether in radio waves or in the visible light, are only narrow windows. Earth has an atmosphere, so much of the part of the electromagnetic spectrum, the radiation is absorbed by this atmosphere. So you can get radio waves. Some part of it is still not, we don't get it, but most of the radio part of the spectrum, you can get if you go to very high altitudes, you can get some part of the infrared spectrum, the visible light, yes. But anything more than that, the ultraviolet, the X-rays or the gamma rays, you have to go up in the atmosphere. So here, this is 50 kilometer. So you need to at least go on a balloon or rocket flies or on a satellite to look. You have to carry instruments in any of these platforms to observe sources in other wavelengths. So that's exactly what we do. Very early on, there were balloon flights. In fact, balloon flights are done even now in Hyderabad. TIFR runs a facility for balloon flights, and they take you up to about 25 kilometers or so. There are rocket flights that still happen at Tumba and Sriharikota, where it can go up to 100 or 120 kilometers or so. So you still can do that, but again, they are also short-term experiments, right? If you carry an experiment on a rocket, it's for a few minutes. But still they are done and they have their own advantages. Now, so we said you can see these different parts of the electromagnetic spectrum from space. So what is the gain? So just to give an example, this is Earth. This is Earth seen from space in different parts of the electromagnetic spectrum. So because the visible, it's very obvious, I've not put that in, but look at the Earth in X-rays. You can actually see only the poles of the Earth, because the X-ray emission mainly come from the auroras that you see in the poles of the Earth. Here the outline is just drawn for your eye, whereas the emission is only coming from the poles. So in X-rays, it's just the poles. Earth is just an arc like this. This is in UV. This part is the part that is illuminated by the sun. So you don't see the other part here, but you see the structure in UV. This is in the extreme ultraviolet, which is between, which is just short of X-rays. And you see a very beautiful arc here, which is from air glow. That's the Earth's shadow here, the aurora. And this is in gamma rays, and this is in the IR. So just the point here is that when you look at something from different perspectives, what you see is entirely different. And we do need to know that, right? So because if you were looking at Earth only in the visible, you will have certain understanding of the processes that's happening on the Earth. You may not at all come up with something like this, where these high energy processes you can never imagine if you look at it only from in the visible light. So just like this, for every object in the universe, multi-wavelength observations provide a huge advantage. So yes, so we do need to go to space to look at these perhaps familiar objects and even find new objects. So all of this can be perhaps traced back to the point when Rontgen discovered X-rays. So to the students, maybe you can recognize this picture. If not, do Google it and read the story of how William Rontgen discovered X-rays. So this is a X-ray, the very first X-ray photograph of the hand of Rontgen's wife with a ring here, right? So the story goes that like his wife nearly fainted, because this is the first time somebody was seeing your own bones, no? Because you're alive and you can see your bones was something totally new at that point of time. So anyway, so once you started once people recognize that there are other parts of the electromagnetic spectrum that you can make use of, that could be the point where, also thought of looking in space for such objects. But of course, this took a long time. So it's almost 50 years later that the first rocket flights took up to seek for sources that emit X-rays. So the first cosmic source of X-rays was discovered in the constellation called Scorpius, and the object is called SCO-X1. So this is the first rocket flight that took off in 1962. And what you see here is a scan angle. So it's scanning the sky, and at one point, when you reach the point in sky where this constellation is, you see a huge jump in the signal. So that's where they discovered this object called SCO-X1, which is actually a neutron star. At that point, we didn't know, but this was the very famous experiments done by Gaikani in the US. So this was a very, path-breaking discovery that changed, or that really started X-ray astronomy or high-energy astronomy. Today the X-ray sky looks like this. So this is the latest. So when we looked at the time of SCO-X1, that was the only X-ray source other than the sun we knew. But today, with E-Rosetta, which is the latest soft X-ray telescope that's up there, which is doing a survey, you can see how every point here is an X-ray source. So this is a very beautiful picture. You can see the disk of our galaxy here, and these bubbles, which are hot gas, and that's very hot and so emits in X-rays. You can see several of these. So these are our neighboring galaxies. You can see every point here is an X-ray source. So we know so many X-ray sources today, and many of them are in fact not visible in the visible part of the electromagnetic spectrum. Or in other words, with optical telescopes, we cannot study them, or we don't even see them. So for example, those of X-rays which needs X-ray telescopes to measure their radiation. So how this structure is, there is often a compact object, which are either a white dwarf or a black hole or a neutron star, which are like the remnants after a supernova sometimes, or it's at least the end state of a star. So you have such a compact object like a black hole here, and a normal star, and because of the very high gravitational pull, matter is getting pulled from this star into this is just an illustration, because we cannot take such pictures of these distant objects. What we have is just a concept by an artist. So you see this material being drawn from this star as into a disk around it. We call this the accretion disk, and the X-rays we see are from this disk that's around the central black hole, because a black hole itself cannot emit radiation, right? And it could be a neutron star as well. So any of these compact objects do this. Supernova remnants, this is a X-ray image of a supernova remnant. So there is a supernova that happened at the center of this, and you can see that it's like it just exploded. So this is still happening, right? This is expanding still, and you can see the structure here. So when you take this picture, you see there is more emission in this part than on the right. So just by looking at the picture, there's a lot you can say about it. And this is a comet. So comets are usually visible in the optical light, but if you take an X-ray image of it, you see a very bright source of emission in the nucleus and very thin emission around it. So just to give examples of different kinds of X-ray sources. Now, space science is not just high energy astronomy. Broadly, we can say it engulfs planetary sciences, atmospheric science, astronomy and astrophysics, and also aspects like astrobiology, space biology, the fundamental sciences, and microgravity based experiments. We'll just look at how in our country the space astronomy grew. There were initially a SROS series of satellites which carried X-ray, gamma ray detectors to look at gamma ray burst detections. For example, this is a gamma ray burst. So it's a burst in gamma rays. At those times, it was a complete mystery. Even today, it's an interesting field. So this is one of those early detections from our satellite. There were IRS P3 in the Indian remote sensing satellites had piggyback payloads. So the main satellite is for remote sensing Earth, but still you could carry small instruments to look at cosmic sources in the sky. There was a solar X-ray spectrometer on GSAT-2, where we went to the new technology detectors made of silicon semiconductor detectors. RT2 on the Photon Coronas mission used a special kind of imaging technique. And then now we have the AstroSat, which is a dedicated astronomical observatory, which was the first one, and it's going strong. Launched in 2015 into a low inclination orbit. It has 5 scientific payloads. I think many of you might be familiar with it and even using data from this. It's all in good shape and giving us lots and lots of data. Now, over the years, one of the main things about going to space with telescopes is this fact that making instruments for space is very challenging. So I just wanted to touch upon this point, that it's very different from making something for a ground laboratory instrumentation. So you would have had, your physics labs in school and college where you do the experiments, right? So those are instruments which work in a very different environment. But when you go to space, it's ultra high vacuum, right? It's the kind of vacuum that you cannot recreate in the labs here. So what happens? Many of the materials degas, or the molecules that are trapped in the materials come out, which will interfere with your signal, which will contaminate your detector. So you need to use materials which are suited for such high vacuum. There are extremes in temperature. So if you're in space and you're looking at the sun, that part of your instrument is very hot, whereas the part that is looking in the cold space is very cold. It's like extreme sub-Kelvin temperature to very high 300 Kelvin or more. Like if you're looking at the sun, you could go up to 100 degrees Celsius in temperature. So the same instrument has to face these extremes in temperature. Then there is the radiation. When we are on Earth, we are protected by the Earth's magnetic field and the atmosphere. But when you're out there, all the particles that's coming from the galaxy, from the galactic, the different sources in the galaxy called the galactic cosmic rays, then the particles from the sun, all just hit you all the time. So all these instruments have to be radiation hard, or like they have to withstand this. It has to withstand the vibration of a launch. No, by mistake, one of the instruments that you're working on the lab fell to the floor. What will happen? It'll just strip apart, right? And that's it. But then you can go and repair it, of course. Whereas when you send something on a rocket, there is a lot of vibration that happens. You would have seen launch videos, that initial part, there is this vibration that happens, and every instrument that you fly, it should not just rip apart, right? So it should be able to withstand that vibration load, because you don't have, and once you go into space, there is no means to repair. So when you build an instrument, you have to make sure that it works in all these environments, and it will work for a long time, and there is no zero error. I mean, zero error is what you want. Now coming to exploration. So space science is one thing. No? When you look at in astronomy, you look at different sources, which are all points of light, and still you learn a lot about them by looking at the particles or the electromagnetic radiation that it emits. Exploration is much more than that. As long as humanity has been there, we have had this spirit of exploration, right? If there is something that's not achievable, humans have a tendency that we need to see if we can do this. I'd like to quote a few. Marco Polo, the famous Venetian merchant who traveled far and wide, and he also wrote travel logs, which is such a source of information in history for us. Vasco da Gama, who was the first to come to India at Kozhikode in Kerala in 1498. So this is a painting from where he is presented before the king, a total alien kind of feeling. The first is the South Pole, Amundsen, Robert Peary and Henson, who went to the geographic North Pole first, and Sir Edmund Hillary, Sherpa Tanzing, who went to the Mount Everest. So these are just this is also exploration, right? At a time when the world was not so global, these people had the spirit of exploration to find new worlds, to find discover new lands, and to understand the culture, understand the environment. That's how we now, our understanding overall has changed about the whole world. In the same way, the real space exploration kick-started with the launch of Sputnik 1 in 1957, when the Soviet Union fired the small satellite up into the air. So that's the third dimension now. So until then, humans were exploring Earth in all possible ways. But from this, it went into that third dimension of exploration. Now, why do we explore planets? Yes, there is the spirit of exploration, but there is, of course, more to it than that. It's a fundamental question, as we said, on the origin and evolution of Earth and the planets and everything that we see in the universe, the curiosity to explore new environments. So as you will see in some of the slides that I have further on, these are all totally new worlds. Understanding planet formation, how it changes with time. So this is relevant for our planet too, right? Today we are talking about climate change, global warming. So for example, we believe Venus, which is a planet very similar to Earth in size and its composition, we believe now that Venus had even oceans long back, and because of an uncontrolled greenhouse effect, all those oceans evaporated, and today what we see is a very, very hot planet. The surface is like 400 degrees Celsius, and nobody can, there can be no life on the surface of Venus. So looking at other planets, we know how things evolve with time. What are the effects of changes in the atmosphere? What are the effects of sun's radiation on us? Settlements for future. So we are seriously thinking of having permanent settlements on the moon, for example, which is the nearest object that we have, where we have access to. Is there life elsewhere? That is again a very fundamental question, right? So as of now, we know only Earth as a place which is suitable for life to exist. But if you go to the outer parts of the solar system, we have found basic molecules that form amino acids. In comets, there are material that can form long chains of molecules. So these are all the curiosity that leads us to explore other worlds or the planets around us. And many means to study them. From Earth, we use powerful telescopes. We have flyby missions where we take a short time to observe, but those are in many cases much cheaper. Orbiters, landers, rovers, and if there is an atmosphere, we could use balloons on other planets. For example, on Venus, as early as in the 1960s, they had balloons that descended into the atmosphere and took very useful measurements. Human exploration. But for all this, what do we need? There are certain technologies that enable these planetary missions. So, what are those primary things that we need if we want to enable such exploration? So, as we like to explore Earth, we needed very early on ships, or now we have aeroplanes. You need fast bullet trains to travel to places. So that's what is enabling it, right? Whereas when you go to other planets, what are the main technologies that enable them? Propulsion it's one of the primary things. That is what enables you to get to the planet, right? So there are many ways of chemical propulsion, electric propulsion. There are things like solar sails, where you build, just like in a ship, a very big sail, and you just go very slowly, just pushed by the solar radiation pressure. So there are many ways of doing these. Power to provide electricity sufficient for the spacecraft and the subsystem. Where do you get power in space? You can't plug it onto something on the wall, right? You need power. You need to carry solar panels, but that is in the inner solar system. Now, if you go out into the Jupiter or beyond, where the sun's light is very feeble and you don't get enough power, you might need radioisotope based power systems. So here, all this requires enabling technologies. Telecommunication to send commands and receive data. You need to when a spacecraft goes into interplanetary space, you need to communicate to them. You need to get back the data, and there is this delay. For to the moon, the delay is a few seconds, but to the Mars, it's larger. And as you go further and further away, the light travel time, there is a light travel time. Therefore, when you send a message and you get it back, there is always a delay. And the whole worldwide, we are on this to try and make this faster and faster. Avionics, the electronics for operating in spacecraft and subsystem have to be different. As I said, the environment there is quite different. So, for example, we have to use what is called radiation hard devices, which can withstand this high radiation in space, like all the protons and electrons and charged particles that's there. So the electronics there should be able to withstand this radiation. So you need special kind of chips and overall electronics in the satellite and in its subsystems. Software for computing and providing commands to operate the spacecraft and subsystem. We cannot always be sitting here and commanding, isn't it? So you need autonomous navigation sometimes. Like you program it that, okay, go to the moon, reduce your speed, land there now. So such things. So for all this, as we progress in this field, the technologies we need are enormous and very challenging. In situ exploration, which means you actually land on a place and look around, that is very challenging, because primarily when you go to an object to reduce the speed of the spacecraft and then enter into an orbit around it, descend and land is a huge task. Autonomous mobility, as I said, is required because you cannot always wait. You're very near, like in this picture, you're very near to the surface of the planet. You can't stop the lander to wait for our command. It should have the autonomous ability to look for hazards. When as it lands, if you see a big boulder, a big rock sitting there, you should move to the right or the left. So such kind of decision making on board has to be built in for successful missions. Technologies for severe environments, the environment that we see in these planets are entirely different. Anything that unlike that we see on Earth. As I said, for example, on the Venus surface, it's 400 degrees Celsius, so where lead will melt. So you can't make material, you can't have instruments or the lander materials with the usual what we use in terrestrial labs. And so everything that you do need to withstand these extreme environments. Sample return is another very, very immensely useful, especially for things like finding the absolute age of planets, for example. Like we have samples from the moon, from the Apollo missions, the Russian missions, and recently from the Chinese missions. All of this has made a big breakthrough in our understanding of planets, because we have these things in our lab and we can do radioactive dating and find the absolute age of these materials, which is never possible by just in situ landing or roving or any other remote sensing measurements. So these are very important steps in the exploration of planets. Rovers, so you're all probably familiar with the Perseverance rover that's now on Mars. It's a huge one with these 6 wheels. There are also always new technologies that are emerging. Just to give an example, here is a spider rover, which helps it climb just like a spider. The planetary exploration in the last 50 years has progressed so much. You can call it, this is the age of planetary exploration. And the first spacecraft that ever went to another planet was not Moon, but in fact Mariner 2, which did a successful flyby of Venus. And for the first time, it confirmed that Venus has a very high surface temperature and it doesn't have a magnetic field. So that was just a flyby, but then it was very useful because this was a confirmation that Venus was unlike anything that we know. In India, the rise of planetary program is in fact in the 60s. There were study of many of these extraterrestrial samples at TIFR, at IIT Kanpur, and at the Physical Research Laboratory in Ahmedabad in the 1960s to 80s. Cosmic ray tracks and meteorites. So meteorites are another source, right? That where you don't need to spend a lot of money, right? Because you can go in search of meteorites, especially in the northwestern part of India, in the deserts. It's easy to find a meteorite. So there are these meteorite hunters who would go and pick these samples, and there are Antarctic expeditions done just to look for meteorites because it's easy to see in the snow. And we have a very large collection of such meteorites in India as well as in the globally. So many of these studies started very early in India, as I said, in the 1960s, and there are more than 100 publications here. You can see here PRL, Professor Bandari receiving the Luna 24 samples in 1977. Planetary astronomy in India also started early, with the discovery of the ring systems of Uranus in 77 by telescopes at the Indian Institute of Astrophysics. And many observation of comets and asteroids were done and still happen. And the space age in India, as you would be familiar, really began with the first sounding rocket that was launched in 1963, and then ISRO started in 1969. And the first satellite of ISRO, which is Aryabhatta, in fact, had an X-ray payload. So at the beginning of astronomy is as old as our space program. The thrust was, of course, on remote sensing and communication satellites in the early era, but always, as we look back, there were space science payloads in many of these missions. Just a glimpse of the new worlds. For example, these are the 3 planets, Venus, Earth, and Mars, and their spectrum. So spectrum is this is the wavelength on the x-axis, and this is the reflectance of light on the y-axis. You can see these signatures. So for example, this is a signature of carbon dioxide. You know, Mars and Venus have very high content of carbon dioxide. This is the region of water, which is there on Earth, but not on Venus and Mars. And this is ozone layer on Earth shown here. So the curious thing, or a very fundamental question that we would like to know in this planetary exploration is that you remember we began with how solar system formed. So around the young sun, all these planets formed roughly at the same time in the same environment, but yet today you look at it, they have all evolved so differently. So what led to that? This is Moon and Mercury, which looks very similar. They are both very rocky, but Mercury has a very heavy iron core where Moon doesn't have. Both have water ice at the poles. So this is of Moon and this is on Mercury. There's a very high resolution image of a part of the Moon by the Chandrayaan-2 optical camera. You can see the details, how much details are revealed. So when we looked at the pictures from astronomy, they are point sources of light, right? And you do learn a lot by looking at an image or the spectrum, or just by looking at how the intensity varies with time. But whereas when you come to planetary exploration, you also have such very detailed pictures and you have samples in hand. So the amount of information that you have is multifold. Moon is a very interesting object that we are all excited about because it's the key to the history of evolution of all the terrestrial planets. It's a body that we have access to, we have samples from, and a place where we can settle. It's 4.5 billion years old. The surface is as old as that, and there has not been much changes, unlike for the other planets. Like Earth, a lot has changed. We don't have our full history from the 4.5 billion years, but just the neighboring object, Moon, has all the evidences we need to build that, what happened in the last 4 billion years. And as I said, it's an outpost for the future. There is scope for mining, sample return, and to try out new technologies such as rover mobility on another planetary body. So it's always seen as a gateway or a stepping stone for further exploration. There are active moons like this. These are the water plumes at Enceladus, which is a satellite of Saturn, from a spacecraft called Cassini. What is special about this is these are plumes which shows that the planet is very active, and these are water plumes. So water is always associated with the possibility of life, and therefore Enceladus is a very prospective planet to visit to. There's a volcanic eruption that's happening on Io, which is Jupiter's moon. The landscapes at Mars, which are very different, and there are also similarities with many landscapes on Earth, like this polar ice caps that keeps changing with seasons on Mars. This is the inner walls of a crater on Mars, where you see this erosion or like flow that indicates that water might have flown there in the past. This is our images from Venus. It's a Venera 9 image in 1976. You can see these a very tattered kind of surface, many different structures that is unfamiliar to us in any other planet. So they're named coronae here, believed to be a result of volcanism on Venus. Coming to the end of it, there are many new environments that challenge our understanding of physics, chemistry, and biology. So as we started, we said our basic question is like, how did all this happen? Where are we? Which part of this universe are we in? What's going to happen to us in the future? But as we explore many of these new environments, not just planetary, but the stars and the galaxies, all of them challenge our understanding of, fundamental understanding of physics, chemistry, and biology. Innovative new technologies result from such exploratory programs. Many of these things, we don't even need to think of new technologies, right? When you're exploring Earth, there is a limit to the technologies that are required. But as you explore further out in space, we are challenged to bring out new technologies which have uses elsewhere as well, because it leads to the overall progress in technology development in our country. There is also the social and cultural impact of planetary exploration, which is very profound. Makes us feel, for example, this is a famous painting called Kissing the Earth by Apollo 12 astronaut Alan Beans, which is considered one of the very profound paintings ever, because as you look at moon as you look at Earth from moon, you get the feeling of planet home, which is also a very important aspect in today's world. So the strength of programs in India is that we have a growing research community. So this is the right time to grow. There is a lot of scope. We have relatively quick access to space platforms. The space program in India is capable of launching instruments to low Earth orbits, geo orbits, planetary orbits. There are these microgravity experimental platforms. There is a PSLV fourth stage platform, sounding rockets, and there is also support and funding from ISRO towards realization of many of these science experiments, especially to the universities and academia and to the students. How do you get into it, and what do you need to do this? You develop your analytical skills. Whatever you're learning in class, try to apply it, improve your skills in experiments, build expertise in analysis methodologies, in computational tools. And your approach is what is the most important. You define analytically state equations, defining your problem, calculate sample initial conditions, inputs, how things change when you change the inputs, learn to plot, animate the results of your computation. It's also important how you present your results and how to draw conclusions and how to come up with improvements required for the next iteration, and how you so basically, since you are all college students and you're learning these various subjects, in any area that you do, the basic fundamental strength that you need to build in is to how to approach a problem and draw the conclusions in it. So I'll end with this. Also, to just mention that data from many of these space science missions are absolutely free and available on the web, and there is a lot of help also out there how to use it. User guide software. There are citizen science projects like this PKC in Pune, where there are a lot of help available to do for non-experts to look at data. So be proactive, read, do experiments, and would be very happy to be of help for any of these. Thank you. So that is all I have. Hello.
Thank you so much, ma'am, on the behalf of all our team. It was a very great pleasure to listen you, and in a very interesting topic.
Hello. I'm not. Yeah. Yeah. Please go ahead if you have any questions.
Ma'am, it's a humble request, kindly switch off your presentation mode. So
Yes,
we'll
sure.
be able to, yeah, we'll be able to.
Is that visible?
Yes, it is still visible.
Okay.
Ma'am, kindly stop presenting your slides, please. Thank you so much. Thank you so much, Dr. Shaman and ma'am. Now, I would like to invite our second speaker of the day, Dr. R.C. Dubey sir. Before his words, I would again request Honorable Vice Chancellor of the University to speak and bless us with few words. Honorable Vice Chancellor sir. Honorable Vice Chancellor sir. I am requesting Honorable Vice Chancellor sir for blessing us with his kind words. I think there is some technical issue. He will be with us in few after some time. Now, I introduce my second speaker of the day, Dr. R.C. Dubey sir. He had completed his master's and doctoral work in botany subject from Banaras Hindu Vishwavidyalaya, Banaras. He also served his duty in many distinguished posts. Only few are Director Internal Quality Assurance Cell IQAC, Dean Faculty of Medical Sciences and Health, former Head Department of Botany and Microbiology,
हाँ मैं
former Institutional Animal Ethical Committee, former Dean, Faculty of Life Sciences and many more. He has been a long academic profile with 34 years of research and teaching experience. He guided 27 students for their doctoral work, published 17 books, and approx 200 research papers. For this, he has a long number of citation index in Google Scholar with approx 4,400 in numbers. He also honored with Certificate of Merit from Vice Chancellor of Banaras Hindu Vishwavidyalaya, Banaras. We have a huge list of his excellence, but as we and our listeners are eagerly waiting for his words, before inviting him, I would like to request Honorable Vice Chancellor Sir for blessing us with few words. Jesse, will you repeat? I think there is again some technical issues, and apologize for that. I am very humbly inviting our respected Dr. Dubey sir for his lecture. Over to you, sir.
Thank you, ma'am, for inviting me to deliver a lecture in this week-long program. Is it visible? Week-long program.
डॉक्टर दुबे जी
हाँ, नमस्ते।
हाँ, आप नमस्कार। आपका जो पावर पॉइंट है वो यहाँ से बिल्कुल साफ दिखाई दे रहा है। मैं बीच में कुछ काम से व्यस्त था। मैं आपका पंडित रविशंकर शुक्ल विश्वविद्यालय में स्वागत करता हूँ, अभिनंदन करता हूँ और धन्यवाद भी ज्ञापित करता हूँ कि आपने हमें समय दिया, हमारे विद्यार्थियों को, हम सबको इस विषय पर ज्ञान देने के लिए उपस्थित हुए। मुझे ये बताया गया है कि मेकिंग द फ्यूचर ऑफ इंडिया थ्रू साइंस टॉपिक पर आप का व्याख्यान होगा। आप जैसे विद्वान वैज्ञानिक जब हमारे साथ जुड़ जाते हैं तो हमें लगता है कि हाँ, हम सब आपके ज्ञान से लाभान्वित होंगे। हमारे विद्यार्थी, हमारे शिक्षक सब जुड़े हुए हैं, वे लाभान्वित होंगे। आपका एक, मैं बीच में थोड़ा दूसरे काम में लग गया था। मैं सुनूंगा, बीच में सुनता भी हूँ और आपका बहुत बहुत पुनः स्वागत करता हूँ। नमस्कार, आप अपना व्याख्यान जारी रखिए।
अच्छा, बहुत बहुत धन्यवाद, बहुत धन्यवाद आपको। तो मैंने टॉपिक ये डिसाइड किया है, मेकिंग द फ्यूचर ऑफ इंडिया थ्रू साइंस एजुकेशन। मुझे मालूम था कि ढेर सारे जितने एक्सपर्ट्स हैं वो अपने लेक्चर अपने अपने विषयों पे शोध पर देंगे, जिनका जैसा काम है, इसमें जिसकी एक्सेलेंसी है, स्पेशलाइजेशन है, उस पर लेक्चर देंगे। लेकिन मैंने इस लेक्चर में ऐसा कुछ नहीं है जिसमें मैं अपने स्पेशलाइज चीजों को ही फोकस करूं। मैंने कोशिश किया है कि ये जो मेरा लेक्चर होगा ये ओवरऑल ग्लिम्स ऑफ पास्ट एंड प्रेजेंट इंडिया का होगा। कुछ मोटिवेशन जो अभी यंगस्टर्स हैं उनके लिए होगा और थोड़ा सा मैं अपने भी काम को बताऊंगा जो अभी अनटच्ड रहा है। तो मैं कोशिश करूंगा कि किसी को बोरियत ना हो और अच्छा लगे। दिस इज माय अटेम्प्ट टू गिव सम ग्लिम्सेस ऑफ मेकिंग द फ्यूचर ऑफ इंडिया थ्रू साइंस एजुकेशन। जैसे कि for the first time this science has been considered to celebrate as in the form of festival by the government of India, putting this slogan Vigyan Sarvatra Pujyate. This is the hybrid of three words, Vigyan Sarvatra Pujyate, Sanskrit and Hindi. If it would have been written as Vigyanam Sarvatra Pujyate तो इसमें पूरा संस्कृत ही दिखाई देता, लेकिन दिस इज ए हाइब्रिड है। Government has decided to celebrate in different form at the time of 75th Azadi Ka Mahotsav. I want to emphasize here that this Vigyan means Visishtam Jnanam iti Vigyanam. ज्ञान तो है, एक तो ज्ञान होता है, दूसरा विशिष्ट ज्ञान, ज्ञान में ही भी विशेष तरह का ज्ञान। मैं बताऊंगा आपको यह विशेष तरह का ज्ञान क्या है। और यह जो विशेष तरह का ज्ञान है, दिस इज नॉट न्यू इन आवर पास्ट इंडिया, पास्ट आर्यावर्त, पास्ट भारतवर्ष। इट हैज बीन मेंशन इन तैत्तिरीयोपनिषद, विज्ञानम ब्रह्मेति व्यजानात्, विज्ञानेन जीवाणि जीवन्ति। विज्ञान ही ब्रह्मांड, ब्रह्म है, विज्ञान ही ईश्वर है, और इस विज्ञान के कारण ही जितने भी जीव जंतु हैं वो जीवित रहते हैं। तो कितना बड़ा ब्रॉड कंसेप्ट हमारे उस प्राचीन काल के ऋषि वैज्ञानिकों ने दिया। मैं तो उन सारे ऋषियों को वैज्ञानिक समझता हूं, उनको नतमस्तक होता हूं कि उन्होंने एक जो विशेष ज्ञान का उद्भव किया, ये हमारे लिए आज प्रेरणादायक है। कुछ चीजें मैं इस पर शेयर करूंगा। लेकिन मॉडर्न साइंस में वी ऑलवेज डिफाइन दिस साइंस एज वेल ऑर्गेनाइज्ड, वेल मैनेज्ड एंड ऑर्डरली इवॉल्व्ड नॉलेज ऑफ एनीथिंग। हियर द नॉलेज इज a science, and getting the knowledge we have to search this knowledge in a systematic investigation. What for? To establish novel fact, to solve new or existing problem, prove new idea or develop new theories. यह आता है इसके साइंस में। जैसे मैं यहाँ पर एग्जांपल देना चाहता हूं, कुछ वर्षों तक यहाँ कोरोना नहीं था हिंदुस्तान में। साइंस वाज एग्जिस्टिंग अबाउट द कोरोना वायरस। कोरोना वायरस माइक्रोबायोलॉजी में पढ़ाया जाता था 2008 के आसपास, और 1998 के आसपास कई जगहों पे ये सार्स वायरस को रिपोर्ट किया गया। वैसे तो 1960 से ये रिपोर्टेड है, लेकिन इतना ज्यादा ज्ञान होने के बावजूद भी इतना ज्यादा पूरी दुनिया में जो मार्टेलिटी हुई है ड्यू टू कोरोना वायरस, दिस इज वेरी सैड कंडीशन। साइंस था बट देयर वाज नो टेक्नोलॉजी, रिसर्च भी था, देयर वाज नो टेक्नोलॉजी। तो यहां पर साइंस, टेक्नोलॉजी, नॉलेज, रिसर्च, इन तीनों का कॉम्बिनेशन यह डेवलप करता है किसी देश की उन्नति के लिए। हम केवल साइंस पढ़ते हैं, करते नहीं हैं। हम रिसर्च करते हैं, वी कलेक्ट डेटा, वी गेट डिग्री, बट वी डू नॉट वर्क टू डेवलप टेक्नोलॉजी। जितने भी पेटेंट हो रहे हैं हिंदुस्तान में, कह लीजिए हिंदुस्तान की बात बता रहा हूं, केवल 6% साइंस के जो रिसर्च है वो पेटेंट होकर के निकल रहे हैं, और उसमें भी जो पेटेंट हैं मानव सभ्यता के लिए काम करने के लिए दे आर मेगर, बहुत ही कम है पेटेंट। क्यों? क्योंकि हम केवल पेपर पब्लिश करते हैं, साइंस करते हैं, नॉलेज गेन करते हैं, वो प्रमोशन को ध्यान में रखते हुए, नॉट फॉर द कॉज ऑफ द सोसाइटी, नॉट फॉर द cause of the upliftment of nature. So we have to change our idea, because if we are not changing our idea, the nation will not develop. So for that, what we have to do, make to think, always try to think what you have to do. For that, you have to develop devotion, what you are thinking, and whatever you think, try to transfer your knowledge in the form of techniques, in the form of technology, and there we need a dedication. I want to emphasize here that science must be done for the society. It is the society that creates where there are problems existing since several years, several decades, I can say. So society is needing the science to be done in more greater detail. So science can solve the problem, and you can take the example from the history. History will tell you about your past. आप कौन थे पहले? एक मैं भारत भारती की कविता सुनाना चाहता हूं। हम कौन थे, क्या हो गए और क्या होगे अभी, आओ विचारें आज मिलकर ये समस्याएं सभी। यह समस्या ये पास्ट में भी थी, यह समस्या इस समय भी है, यह समस्या भविष्य में और विकराल रूप विकराल रूप ले सकती है। सो फॉर दैट यू हैव टू induce the culture, you have to inculcate the culture of the science so that technology may develop. And technology, what for? To solve the problem of the society, to solve the problem of the whole globe. Global peace is required here. We did science in the past, we achieved many more, we developed techniques. Now there is no peace. So science needs peace. Just to see what is happening between Ukraine and Russia, what is happening in the United Nations organization, what is happening in the whole globe. Science has developed, technology has developed much, but there is no peace. So for that, science always needs peace. We have to work out on that. And our country has been a leader country to play a crucial role as far as science and technology is concerned. So need-based technology must be developed. Where? In the space, for defense, for water, vaccine, agriculture, food, dairy, health, medical science, pharma sector. There are many more areas. I have grouped only a few just to make you aware. There are many more areas where there is a need of science and need of development of technology to solve the problem which may come in near future. You know that in India, in our country, the babies are born in different socio-economic conditions. According to their problem exists in the society. Some are fortunate to learn to get school to learn the knowledge by using laptop and computers. They are sitting on the table, and there are many more poor. They are not getting such facility. They are sitting on the ground, writing and learning on the slate and pencil, and many more are not getting such opportunity. They act as bond labor. Just you see this scenario in this country, in this situation. Can we think about the science, about the development of technology that may solve the problem of million of the forfeited people? Or that you have to apply our mind. Government has developed many more facilities and people go there. They learn technique, they learn science, but the use of the science is going in two different directions. One direction is the right direction, where persons like Abdul Kalam, missile man, has been produced. Other direction is people are going in depression. They are committing suicide. They are getting failed not to take proper decision at proper time. They don't have courage to struggle in this society, in this world. And other group is there. They have science, they have technique, they have technology, and they have adopted the path of terrorism. Those who are being caught, they are hanged to death. So where is science? Where is a mind? There is a need of switching the mind of the people. We all are having a brain. In that brain, there reside. In their brain, there reside mind. And according to the mind, the soul becomes strengthened and we develop spirit. So there is a interface between science and script, brain, mind, soul, and spirit. And the duty of the teacher is to brainwash the student. Just going to the past Bharatvarsha, to which we say as Aryavart. As I told you, the scientists of Aryavart were rishis in the ancient India. Rishis gave many more concepts. Thousands of names are found in our script, in our literature, where rishis have developed this one, this rishis have developed this one, this rishis have developed this aspect, this area. We have forgotten. Rishis have given the concept of the family. in one family how we have to live, how we have to behave, because family as family make a society, several society makes a district, a taluka, and several districts makes a state, and several states make a country. So we have to focus on the individual. Atharva says anubratah pituh putro mata bhavatu sammana jaya patyay madmatim vacham madut santivan ma bhrata bhrataran dikshan ma susa ramtas susa सम्यंच संप्रदा भूतवा वाचम मदद भद्रा। हम ऐसे परिवार में रहें जहां पर पिता पुत्र पिता का आज्ञाकारी हो, पुत्र माता पिता का आज्ञाकारी हो, और जो पत्नी है जाया पत्ते मधुमतिम वाचम भद्र संतिमान, जो पत्नी है वह भद्र बातें बोले, कोई कट वचन न बोले। और एक परिवार में भ्राता भ्रातृन दीक्षण माँ सुसारन सुस्ता, छोटा भाई बड़ा भाई, ताऊ चाचा दादा दादी भाई बहन, इस सारे मिलकर के इस तरह से रहे। वाचम मदद भद्रा, अच्छी वाणी बोले, अच्छी बातें को सीखे। यह एक फैमिली कंसेप्ट था जो अथर्ववेद में हमारे उस साइंटिस्ट ऋषियों ने दिया। मैं तो उन सारे ऋषियों को साइंटिस्ट कहता हूं। और जो टीचर का रोल है, टीचर कहां से शुरू होता है? द कंसेप्ट ऑफ ए टीचर डेवलप्स फ्रॉम द होम। The best teacher is mother, followed by father, and then the students come in the class. Students are the future of India. A good citizen means good country. If citizens are not good, they cannot shape the country. They cannot change the fate of the country. So there is a need of changing the mind of each and every citizen, particularly school-going boys, because the education plays a greater role in shaping the life of the student, and education developing the mind, inculcating the ethos of our past in their student is the need of the hours. And they must obey this country as the Matrabhumi. They must not consider this country as Bhumi Matra. इस देश को लोग भूमि मात्र न समझे, इस देश को लोग मातृभूमि समझे और कहें पुत्रो अहम पृथिव्या, हम इसी पृथ्वी के भूमि पुत्र हैं। और जब यह कंसेप्ट डेवलप होगा तो कोई भी व्यक्ति अपने देश को जागृत करने के लिए, एक टीचर भी अपने देश को जागृत करने के लिए आएगा। और हमारे ऋषि ने कहा वयम राष्ट्रे जागृयामि पुरोहिता, हम जितने पुरोहित हैं, शिक्षक हैं, आचार्य वर्ग हैं, हम अपने राष्ट्र को जागृत करेंगे। ऐसा संकल्प लिया था हमारे ऋषियों ने। लेकिन कालांतर में समय बदलता गया और आज परिस्थिति हो गई विज्ञानम सर्वत्र पूज्यते, सेलिब्रेट करने के लिए, जबकि सेलिब्रेट न करके यह हमारे संस्कार में आ जाना चाहिए था, जो नहीं आया। मैं बिल्कुल नकार नहीं रहा हूं कि नहीं आया है, लेकिन नंबर ऑफ पर्संस में जो यह है उसमें बहुत कम है। हाउ टू चूज ए करियर आफ्टर 12th, मुझे लग रहा है कि 12वीं के भी बच्चे होंगे, क्योंकि दिस इज जस्ट ए टाइप ऑफ सेलिब्रेशन। तो हर तरह के, हर किस्म के स्टूडेंट भी होंगे, टीचर भी होंगे, रिसर्च स्कॉलर होंगे, आई डोंट नो। लेकिन जो किसी के घर में बच्चा बच्ची है तो हमेशा आइडियल एज ऑफ टेकिंग ए डिसीजन इज 13 to 14 years। नो योर इंटरेस्ट स्टूडेंट के लिए है कि अपना इंटरेस्ट देखें कि हमको क्या पढ़ाई करना है, किधर जाना है। Since the decision to pursue a career after 12th is such an important one, get advice from your family. Mother, father अच्छा सलाह देंगे, आपके अच्छे जो फ्रेंड हैं वो भी अच्छा सलाह देंगे, और टीचर्स को बेस्ट फ्रेंड आप बनाओ। पहले तो टीचर को लोग गुरु कहते थे, गुरु आर जस्ट लाइक मदर एंड फादर, लेकिन आज मैं तो कह रहा हूं टीचर को आप फ्रेंड बनाओ। टीचर को अगर आप फ्रेंड बना लोगे तो बहुत सी जानकारी आपको देंगे, और किसी भी स्टूडेंट के लाइफ को चेंज करने के लिए टीचर्स प्ले ए वेरी ग्रेटर रोल। एंड चूज द राइट कोर्स, नो द फ्यूचर प्रॉस्पेक्ट, भविष्य में हमें क्या करना है इसको सही स्थान चुनिए। चूज ए करियर दैट सूट यू, साइंस की तरफ जाना है, कॉमर्स की तरफ जाना है, आर्ट्स की तरफ जाना है, देयर आर मेनी मोर एरियाज ओपन टू यू। डोंट गेट कंफ्यूज, बायोलॉजी पढ़नी है, कॉमर्स पढ़ना है, क्या पढ़ना है, यह इस सब का चुनाव तो आप लोगों को ही करना है। और जब इसका आप चुनाव करोगे तो कंफ्यूजन नहीं होगा। इसलिए किसी भी एरिया का, हर एरिया में तो कहता हूं हर एरिया अच्छा है। हिंदी भी अच्छी एरिया है, जो हिंदी नहीं जानते उसके लिए अंग्रेजी भी अच्छी एरिया है। आप कुछ नहीं करो, घर में बागवानी करो, वह भी अच्छी एरिया है। मेडिसिनल प्लांट को आप प्रोड्यूस करो, वह भी अच्छी एरिया है। समाज सेवा करो, वो भी अच्छी एरिया है। यू हैव टू सिलेक्ट इट आउट। क्यों? क्योंकि राष्ट्र के निर्माण में इन सब की चीजें एक कंपोनेंट का काम करती हैं। ऑल दीज आर वेरी मच इंपॉर्टेंट। कुछ लोग कहते हैं देयर आर 7 कैरियर्स, 7 ऑप्शंस which are very important. 93% इंडियन स्टूडेंट्स आर अवेयर ऑफ ओनली 7 करियर पॉइंट्स जो मैंने बताया। लेकिन पेरेंट क्या कर रहे हैं? और सब क्या क्या है? जैसे इंजीनियरिंग में लगभग 24% बच्चे जाते हैं। अकाउंट एंड फाइनेंस में केवल 12%, मैनेजमेंट में 6%, मेडिकल साइंस में 8%, लॉ में 4%, डिजाइनिंग में 6%, कंप्यूटर आईटी में 9%। लेकिन इसके अलावा भी ढेर सारी एरिया है जो करियर काउंसलिंग जो भी करते होंगे वो आपको बताएंगे, आप वहां से सीख सकते हो। नाउ एक सर्वे किया गया, हिंदुस्तान में एक सर्वे किया गया। इट वाज फाउंड दैट स्टूडेंट्स आर लूजिंग इंटरेस्ट इन देयर स्टडीज। साइंस तो आप भूल जाओ, वो पढ़ने में उनका मन ही नहीं लगता। और पढ़ने में मन क्यों नहीं लगता, उसका भी कारण है। लैक ऑफ इंटरेस्ट कैन बी काज्ड बाय डिफिकल्टी इन कंसंट्रेटिंग। उनका मन नहीं लगता है, ध्यान नहीं लगता है। सो देयर इज अ नीड टू स्विच ओवर देयर कंसंट्रेशन। दे हैव सेवरल फैमिली प्रॉब्लम सच एज फीस। आप मजदूरी करते हैं, दिहाड़ी करते हैं, there are several other expenses also. Sometimes emotional difficulties are also induced by the friends. जो उनके मित्र हैं, उनकी संगति है, कुरीति है, और सोचते हैं कि मैं तो नहीं पढ़ रहा हूं यार, तू भी ना पढ़, जाने दो। और कभी तो ड्रग एडिक्ट हो जाते हैं। ढेर सारे ऐसे लोग हैं जो ड्रग एडिक्ट हो जाते हैं। मेरे संपर्क में छत्तीसगढ़ के का एक लड़का मिला था। एक बार मैं घासीदास यूनिवर्सिटी में लेक्चर देने आया था। उसका भाई बीटेक कर रहा था, ही वाज ड्रग एडिक्टेड। तो यह संगति का असर है। इसलिए गलत संगति में नहीं आना चाहिए, हमेशा बच्चों पर मॉनिटर करना चाहिए। लर्निंग डिसेबिलिटी and many more factors. Therefore, a teacher has to be the best for the student, to give proper advice to the student, and they can say this is good area, this is bad area, do this one according to their family conditions, according to the fees, according to expenses, according to liking and disliking. And encouragement of science must be done to the student. And no country can progress without science and research, because progress, how far this country will import the things for our benefit. कब तक हम बाहर से सामान को खरीदते रहेंगे? लैपटॉप भी कब तक चाइना से मंगाएंगे? मोबाइल कब तक हम चाइना से मंगाएंगे? क्या हम अपने देश में आईसीटी सेक्टर में इंकरेज किया? ऐसा इन्वायरमेंट हमने तैयार किया क्या कि अपने देश में ही इन सारे का प्रोडक्शन हो? हमने इन्वायरमेंट नहीं तैयार किया। क्यों? क्योंकि हम फ्री में सबको सब्सिडी बांट रहे हैं, फ्री में सबके घर में अकाउंट में पैसा डाल रहे हैं। हमने वह इन्वायरमेंट नहीं किया। ये जो वोट की राजनीति है उसके आगे देश इज सेकेंडरी। इसलिए मेरा सबसे निवेदन है कि जितने भी टीचर हों वो साइंस की तरफ, साइंस रिसर्च एंड टेक्नोलॉजी की तरफ बच्चों को प्रमोट करें। बिकॉज नो कंट्री कैन प्रोग्रेस without science research and developing the technology. Science solves our every problem and every need of the life. Science is a vast field with numerous branches. You can choose any branch of natural science like physics, chemistry, biology, formal science like mathematics, theoretical, computer science, logic, engineering, medicines. Even more advanced branches are data science, robotics, blockchain, microbiology, biotechnology, pharmaceutical science, and many more areas. Language, drama, any area, art, कुछ भी आदमी का इसका चुनाव कर सकता है। अमेरिका में हिंदुस्तान की जो नीम की दातुन है वहां बेचा जाता है, हर्बल टूथब्रश करके। हमारी चीज, हमारी धरोहर अमेरिका बेच रहा है, लेकिन हमें नीम की दातुन का ब्रश करने में शर्म आती है। वी डिपेंड अपॉन टूथपेस्ट, हम अपने पास्ट को भूलते गए। Now, steps in conducting science and research is to identify the problem. Start with the identification of the problem. What is the problem existing with this society? Societal problem is great. A large number of problems exist and it is endless. Put question and prepare hypothesis. आप अपने आप उस प्रॉब्लम को सॉल्व करने के लिए प्रश्न करिए, और प्रश्न करने के बाद आंसर अपने आप आएगा। एक into research. Research is a path. Research is a tool, and you will develop technology, and technology is also a tool, and this tool results in the product, and that product will come in this society, and problem of the society will be solved. So these are the steps where we have to focus and develop a culture of science and research in our country. मैं थोड़ा आपको पास्ट में ले जाना चाहता हूं। कितना पास्ट है? कई हजार वर्ष पहले, एक दो नहीं, कई हजार वर्ष पहले मैं ले जाना चाहता हूं। आप लोग सोचते होंगे कि फिजिक्स में अणु और परमाणु का वर्णन आज आधुनिक युग में किया गया है। फॉरगेट इट। परमाणु का वर्णन श्रीमद् भागवत में आता है। परमाणु सा विज्ञो निराकार, that cannot be disintegrated further and always exists in an uncombined form is called as atom. एटम की परिभाषा कहा गया है smallest constituent of matter, माने चरमः, that cannot be distinguished further सत विशेषाणाम and always exists in uncombined form अनेको संयुक्त सता। they are not combined, they are असंयुक्त। अनेका, they are many, उनको कहा गया है परमाणु। परमाणु सब विज्ञेयो, they are known as परमाणु। और परमाणु, दो परमाणु मिलकर के क्या बनाएंगे? एक अणु बनाएंगे। जैसे ऑक्सीजन, हाइड्रोजन गैस बन गई ना। यहां पर है अणु दो परमाणु, माने परमाणु मिल करके अणु, दो परमाणु मिलके अणु बना लिया। स्यात् त्रसेणु स्मृतः, और तीन परमाणु मिलके त्रसरेणु बना लिया, ट्राइडेंट बना लिया। कितना बढ़िया डिस्क्रिप्शन है। अणु परमाणु की खोज हमारे ऋषि साइंटिस्ट ने कितने हजार वर्ष पहले कहा था, और ये श्रीमद् भागवत का है। मैं कोई अपने ढंग से नहीं बता रहा हूं। आई एम गिविंग यू ऑल दीज विथ एग्जाम्पल। You can note this example. You can go through in detail in Srimad Bhagavat. दूसरा मैं बता रहा हूं, Vedic science. There is a concept of sun rays, microorganism health. जो सूरज की किरणें हैं, उनका संबंध माइक्रो ऑर्गेनिज्म से और अपने हेल्थ से, स्वास्थ्य से क्या है? अथर्ववेद में आता है, उद्यन आदित्य कृमिन हंतु निम्रोचना हंतु रश्मिभि ए अंतक्रमयो गवि है। माने उदय होते हुए और अस्त होते हुए सूरज की किरणों का सेवन करना चाहिए। क्यों करना चाहिए? क्योंकि हंतु अंतक्रमयो गवि, वो कृमियों को, माने माइक्रोब्स को, जर्म्स को का अंत कर देते हैं, उन्हें मार डालते हैं। लेकिन क्या रहस्य है? उगते हुए और सूर्य अस्त होते हुए सूर्य की किरणों में क्या रहस्य है? और क्या होता है? आगे अथर्ववेद में आता है, अनुसूर्य मुदयताम हृदय तो हरिमाचते गो रोहित से वर्णेन तेन त्वा परिदध्मसि। कि उगते हुए और अस्त होते हुए सूरज की किरणों का अगर आप सेवन करते हो आपको हार्ट अटैक और जॉन्डिस नहीं होगा। हृदयोतो हृदय घात नहीं होगा, माने हार्ट अटैक नहीं होगा। हरिमा माने जॉन्डिस, ये पीलिया नहीं होगी। यह ऐसा अथर्ववेद में आता है। लेकिन कैसी किरण, सूरज जब उगता है अस्त होता है तो किरणें कैसी होती हैं? गो रोहितस्य वर्णेन, रोहितस्य वर्णेन, लाल रंग की किरणें होती हैं। इस चित्र से आप देख सकते हैं ये उगता हुआ सूरज है, ये दोपहर का सूरज है, और ये लाल रंग का अस्त होता हुआ सूरज है। जो सुबह और शाम की का सूरज होता है लाल रंग की किरणें होती हैं, उस समय इंफ्रारेड बहुत आती हैं, इसलिए लाल दिखाई देता है। इन द प्रेजेंस ऑफ इंफ्रारेड there is synthesis of vitamin D3 and vitamin D होता है, and calcium is a part of call modeling protein, और call modeling protein आपके हृदय को धड़काता है, और वही लीवर में भी होगा तो जॉन्डिस नहीं होगा। जरा देखो कितना बढ़िया वर्णन हमारे ऋषियों ने कितने डिटेल में कर दिया है। आगे वैदिक माइक्रोबायोलॉजी, फूड और माइक्रोबायोलॉजी से क्या संबंध है? कहा गया है धर्म सिंधु में, लवणम व्यंजनम चैव घृतम तैलम तथैव च लेहयम पेयम च विविधम हस्त दत्तम न भक्षयेत। कि नंगे हाथ से अगर कोई भी व्यक्ति आपको नमक, घी, तेल, खाने वाली चीज, दूध या पानी जिसमें अंगुली पड़ा हुआ हो वह नहीं खाना चाहिए। हस्त दत्तम न भक्षयेत, अगर कोई आपको नंगे हाथ से, नंगे अंगुली से निकाल के खाना दे रहा है, परस रहा है, जैसे यहाँ पे देखिए सलाद बना रहे हैं, परस रहे हैं, तो नहीं खाना चाहिए। बिकॉज मिलियंस ऑफ द जर्म्स दे रिसाइड ऑन योर पाम, मिलियंस ऑफ द जर्म। और मैं अगर कैलकुलेट करके बताऊं, 1 मिलियन पर सेंटीमीटर स्क्वायर ऑन द पाम द बैक्टीरिया रिसाइड, 1 मिलियन पर सेंटीमीटर स्क्वायर ऑन द पाम बैक्टीरिया रिसाइड। इसलिए ये नंगे हाथ से नहीं निकालना चाहिए। ये फूड साइंस जो हमारे वैदिक साइंटिस्ट ने दिया था, वैदिक काल में ऋषि साइंटिस्ट ने। और आगे कहा गया है पद्म सृष्टि में, पद्म पुराण में, यह पद्म पुराण के सृष्टि वाले अध्याय में है, हस्त पादे मुखे चैव पंचाद्रे भोजनम चरेद, हाथ पैर और मुंह धोकर खाना खाओ आप। बिना हाथ मुंह और पैर धोए, उस समय पैर धोते थे क्योंकि जमीन पे बैठ के खाना खाते थे। अब तो जमीन पे नहीं बैठते, खड़े खड़े जूता पहन के खा लेते हैं। मैं वैदिक कंसेप्ट बता रहा हूं कि हाथ पैर मुंह धोकर के ही खाना खाना चाहिए। और आगे सुश्रुत संहिता में लिखा है, चिकित्सा स्थान में, न अप्रक्षालितम पाणो भुंजीत, प्रक्षालितम पाणिपादो न भुंजीत, बिना हाथ पैर धोए आप खाना न खाओ। तो कितनी अच्छी बात, क्यों? हाथ पैर मुंह में ये जर्म्स लगे रहते हैं, इसलिए हाथ पैर मुंह को धो करके भोजन करना चाहिए। आगे है यो अक्षौ, अथर्ववेद में, यो अक्षौ परिसर्पति यो नासे परिसर्पति दत्ताम यो मध्यम गच्छति तम कृमि जम्याम्याम। माने आंख में, नाक में और दांत में एक कृमियां रहती हैं, जर्म्स रहता है आंख में, नाक में और दांत में। लेकिन हम लोग तो नाखून काटते हैं दांत से, हमेशा बच्चे भी काटते हैं। देखो ये बच्चा यहाँ पर नाक में अंगुली डाल रहा है, फिर ये मुंह में डालेगा। ये महिला मोबाइल से बात कर रही है तो अंगुली अपनी दांत से काट रही है। इस बच्चे के आंख में इन्फेक्शन हो गया है, आंख में ये फ्लू है, ये एडिनोवायरस करता है। एडिनोवायरस काजेस फ्लू, ढेर सारे हैं, क्लेमाइडिया भी है, एडिनोवायरस भी करता है। इसलिए कहा गया है अनातुरा स्वानि खानि न स्पृशेद निमित्ततः, डोंट टच योर ओन ऑर्गन सच एज आईज, नोज, ईयर्स, माउथ विदाउट एनी रीजन। बिना किसी काम का अप्रयोजन अपने नाक, आंख, मुख में अंगुली न डालो। अंगुली बात दूर, ऋषि कहते हैं इसे टच न करो, न स्पर्श करो। स्पृशेद निमित्ततः, न स्पृशेद, उसका स्पर्श आप न करिए। बिना निमित्त, बिना किसी कारण उसका आप स्पर्श न करिए, क्योंकि आप स्पर्श अगर करोगे तो मुख, आंख में दे विल एंटर, दे विल कॉज डिजीज, और आई फ्लू तो होगा ही होगा। थोड़ी मैं बात आप, जो मेरा भी काम है, अब आपको स्विच और आप करता हूं गंगा पर। गंगा के पानी को पूरा हिंदुस्तान जो भी फेथ करता है, यहाँ आता है, गंगा के पानी को ले जाता है। और अब अकबर के भी दरबार में गंगा के पानी का प्रयोग होता था। अंग्रेज जब कभी जाते थे यहाँ से गंगा का पानी ले जाते थे। और पहली बार ब्रिटिश से एक आदमी आया, उसका नाम था हैनकिंस हैनबेरी। उसने कहा कि इसमें मेडिसिनल प्रॉपर्टी है। गवर्नमेंट ऑफ इंडिया तो बाद में कही, वो तो पहले कहा। लेकिन गंगा का वर्णन, गंगा का पानी का वर्णन, इट हैज बीन डिस्क्राइब्ड इन ऋग्वेद। देयर इज ए मेंशन ऑफ इन नदी स्तोत्र 10 रिवर्स ऑफ इंडिया। 10 नदियों का नाम है, उसमें गंगा भी है, सिंधु भी है, कावेरी भी है, यमुना, रेवा नदी, महानदा, नंदा, और इधर ये जो पंजाब और कश्मीर की सारी नदियों का वर्णन है। लेकिन सब मिला के 10 रिवर्स हैव बीन डिस्क्राइब्ड। आई एम फोकसिंग ऑन ओनली गंगा। गंगा नेम इज स्टार्ट फ्रॉम देवप्रयाग। जस्ट यू सी लेफ्ट साइड देयर इज ए भागीरथी and straight go ahead there is a Alaknanda. Alaknanda arises from Badrinath and Bhagirathi comes from Gangotri या गोमुख। यहाँ पे दिखा गया है there is a glacier. From glacier this Bhagirathi river comes down और यह गोमुख है। लगता है कि यहाँ गाय के मुंह से निकल रहा है पानी, इसलिए इसको गोमुख बोलते हैं। गोमुख इज 18 किलोमीटर अवे फ्रॉम गंगोत्री। 18 किलोमीटर अवे। पहले तो बर्फ होता था, अब आजकल सूखा सूखा है, नथिंग इज देयर। एंड व्हेन दीज टू रिवर्स ज्वाइन हियर एंड द नेम गंगा इज स्टार्ट फ्रॉम देवप्रयाग। इन बिटवीन मेनी मोर रिवर्स कम इन एंड ज्वाइंस अलकनंदा। फॉर एग्जाम्पल अलकनंदा जो रिवर है वो विष्णु, ढेर सारे प्रयाग का नाम है, लाइक विष्णु प्रयाग, नंद प्रयाग, कर्ण प्रयाग, रुद्र प्रयाग और देव प्रयाग। इतने 5 प्रयाग हैं जहां पर अलकनंदा आके मिलती है। इधर से भागीरथी, देन गंगा, यू कैन से। नाउ गवर्नमेंट ऑफ इंडिया कॉल अपॉन द साइंटिस्ट टू वर्क ऑन टू एक्सप्लोर द गंगा वाटर फॉर मेडिसिनल प्रॉपर्टी। लोगों ने अभी कुछ नहीं काम किया। 2015-17 की घटना है। 17 नवंबर 2015 में गवर्नमेंट ने कहा इस पर लोग काम करें, दैट गंगा वाटर हैज मेडिसिनल प्रॉपर्टी। लोगों ने क्या किया आई डोंट नो। मैंने क्या किया वो मैं बता रहा हूं। द रीजन फ्रॉम मेडिसिनल प्रॉपर्टी ऑफ गंगा इज दैट there are many more regions. I have pinpointed 3. 1, there is a presence of bacteriophages, but bacteriophages are present in each and every river of India and abroad, because where there are bacterial species, certainly there would be bacteriophages. So this hypothesis does not have much more meaning. Secondly, flow rate of water. This I want to emphasize that flow rate of Ganga when it comes down from Himalaya, this is very high. It creates turbulence and mixed oxygen, and because this is one of the reason that Ganga water is highly pure. Second is Ganga water even after prolonged storage does not putrefy because of presence of certain inorganic chemicals like sulfate and presence of antimicrobial organic chemical. So these two are the main reasons why Ganga water does not putrefy even after prolonged storage at your houses. This is why people come from different part of India. They collect Ganga water, they bring it to their respective home and preserve for ritual. लेकिन मैं कहता हूं गंगा का पानी केवल रिचुअल के लिए नहीं, गंगा का पानी मेडिसिन की तरफ भी प्रयोग किया जा सकता है और इसमें ढेर सारे केमिकल्स पाए जाते हैं, बहुत ढेर सारे केमिकल्स पाए जाते हैं। देयर इज ए नीड ऑफ ए साइंस टू डू मच मोर रिसर्च एंड नीड ऑफ टेक्नोलॉजी टू एक्सप्लॉइट दिस नॉलेज टू डेवलप इन द फॉर्म ऑफ केमिकल कंपाउंड इन नियर फ्यूचर, सो दैट गंगा वाटर कैन अलोन गिव a large number of chemical compound for solving different type of elements, different type of problems that exist in India. यहाँ पर कंसेप्ट है कि अगर किसी को पेट की बीमारी है, खाना नहीं पच रहा है, या इफ ए पर्सन इज हैविंग डायरिया, गंगा का पानी 5 लीटर आप पी लीजिए, आपके पेट की प्रॉब्लम एक खत्म हो जाएगी। नाउ As far as bacteriophages are concerned, we have also isolated bacteriophages from Ganga water, but this is a general collection. Hundreds of bacteriophages have been reported. Hundreds of bacteriophages. I am giving example of only those bacteriophages that are associated with certainly bacteria that cause disease in a human being. ये सारे लेफ्ट साइड में जो मैं दिखा रहा हूं, यह बैक्टीरिया आदमी में भी बीमारी करती है, लाइक बेसिलस एंथ्रासिस एंथ्रेस करता है, बेसिलस ब्रुसेला करता है, क्लिस्ट्रीडियम डिफाइली गैस गैंग्रीन करता है, ई कोलाई लिस्टेरिया मोनोग्राफा माइकोबैक्टीरियम ट्यूबरकुलोसिस टीबी भी ठीक हो जाती है, स्यूडोमोनास साल्मोनेला टाइफी सिजिल्ला स्ट्रेप्टोकाकस विब्रियो कॉलरी। पहली बार हिंदुस्तान में हैंकिंस हैनबरी ने रिपोर्ट किया था दैट गंगा वाटर इज एबल टू किल द विब्रियो कॉलरी। ये 1895 की बात है। ये सब आप गूगल में सर्च कर सकते हो। ये इसके इन सारे बैक्टीरिया से एसोसिएटेड बैक्टीरियोफाजेज हैं। These bacteriophages are present, and if you are using the Ganga water in purified form, then these phages will certainly kill the bacteria and the disease will be cured. Now, as far as our work is concerned, I assigned this work to one of the students to collect Ganga water and apply on the albino rat. एनिमल हाउस फैसिलिटी हमारे यहाँ है, एल्बिनो रैट पे हमने काम किया और ये पेपर पब्लिश भी किया। जैसे मैं थोड़ा आपको प्रोटोकॉल बता देता हूँ। एनिमल को लिया, 4-4 ग्रुप, 6-6 का ग्रुप बनाया। कुछ एनिमल में हमने ई कोलाई और गंगा वाटर ये दोनों मिला करके पिला दिया। कुछ में स्टेफिलोकाकस ऑरियस, साल्मोनेला टाइफी जो टाइफाइड करता है, ये दोनों पेट में रहता है। गंगा पानी पिएंगे पेट में जाएगा, बैक्टीरिया भी है तो भी पेट में जाएगा। लेकिन गंगा वाटर जब ज्यादा पियोगे तो क्या होगा? दिस एक्सपेरिमेंट वाज डन ऑन द अल्बिनो रैट। वी फाउंड दैट आफ्टर 15 days of treatment, 100% E. coli pathogen was killed, and after 20 days Salmonella typhi was killed, totally killed, बिल्कुल उसका रेजिड्यू भी नहीं बचा। We collected the stools of these animals and sorted out the presence of bacteria in the stools, and we came to the conclusion that after drinking Ganga water, E. coli and Salmonella can be killed by use of Ganga water. In the same way, if there is a Klebsiella pneumoniae, it causes pneumonia. You are taking Ganga water, and in 15 days it will also be killed 100%. And this girl student is working on the albino rat. This is picture. Now, not only that, we isolated the compound, chemical compound from Ganga water. Just you see in petri dishes, these are the bacteria like E. coli, Salmonella typhi, Klebsiella pneumoniae. The lawn was prepared and the chemicals applied. Just to see all these bacteria where this chemical was diffused, they were killed. All these bacteria, they killed. They did not grow in this condition. Now, this is a comparative of Rishikesh water, because people who are coming to Haridwar, they also go to Rishikesh. Similar situation also exists in Rishikesh as well as in Haridwar, where the zone of inhibition of caused by these chemicals are very high, more than 27 millimeter. 27 millimeter is too high. And this is a picture of the intestine. When intestine of the animal was dissected, it was found that where there was the infection was totally cured and healed. My dear student, my dear friend, there is a long journey to learn. The journey to learn is long, never stop journey. That's why in our Vedas it has been mentioned, charayaveti, chalte raho. The journey of learning must not be stopped. अगर जिस समय आपने चलने की सीखने का की यात्रा आपने बंद कर दिया, उस दिन सीखना बंद हो जाएगा। इसलिए चरैवेति कहते रहो। और हमारा वेद कहता है, श्रद्धावांस्तु लभते ज्ञानम। जिसके अंदर श्रद्धा है, जिसके अंदर ज्ञान प्राप्त करने की जिज्ञासा है, जिसके अंदर जिजीविषा है वह आदमी चलता रहेगा, उससे कोई रोक नहीं सकता। तो एक दिन साइंस भी डेवलप करेगा, रिसर्च भी डेवलप करेगा और टेक्नोलॉजी भी आएगी। नाउ स्टूडेंट्स, एकेडमिक सक्सेस डिपेंड अपॉन सर्टेन थिंग्स। ट्रस्ट योरसेल्फ, यू मस्ट हैव डेवलप कॉन्फिडेंस। आप अपने ऊपर विश्वास रखो कि आप जो कर रहे हो वह सही है। एंड ऑलवेज गिव 100%। कोई काम आपको मिलता है 100% उसे कंप्लीट करके ही पूरा करो, इनकम्प्लीट नहीं होना चाहिए। एंड ऑल द थिंग्स आर पॉसिबल। डोंट, एक अपनी डिक्शनरी में आप परिभाषा बदल दीजिए कि आपके लिए हर चीज कठिन है लेकिन असंभव कुछ नहीं। एंड ऑलवेज think your mind that everything is possible, nothing is impossible। आपके जीवन में कुछ असंभव नहीं है लेकिन हर चीज कठिन है। जब बच्चा पैदा होता है, पैदा होने के बाद थोड़ा बड़ा होता है, उसे चलना भी नहीं आता, बार बार गिरता है, लेकिन बाद में वही एथलीट बनता है, बाद में वही हिमालय की चोटी पे चढ़ता है। हमारे यहाँ एक मैडम आई थी अभी 2 दिन पहले, मिसेस संतोष यादव, 2 बार एवरेस्ट की चोटी को फतह किया, 1 नहीं 2 बार। आई सैल्यूट दिस जेस्चर ऑफ सच लेडी। उसका विल पावर कितना ज्यादा। पद्मश्री से सुशोभित किया गया उनको, गवर्नमेंट ऑफ इंडिया ने किया है बहुत पहले। 2 बार एवरेस्ट फतह किया उस लेडी ने। उनका देखिए मनोबल देखिए। इसलिए यू ऑलवेज से आई कैन, आई विल। आप कर सकते हो ऐसा काम, आप फतह कर सकते हो। आप भी इस साइंस की जर्नी को भी आप फतह कर सकते हो, आप अच्छी टेक्नोलॉजी दे सकते हो। ऑलवेज थिंक योर माइंड, डोंट डेवलप नेगेटिव थिंकिंग योर माइंड। नहीं जानते हो क्या है, मैं आपको एग्जांपल बता रहा हूं, एक एग्जांपल से आप समझ जाओगे। जिस समय महाभारत का युद्ध हो रहा था, उस समय अर्जुन ने अपने सारे रिश्तेदार और सेनाओं को देखकर कहा, मैं युद्ध नहीं लड़ूंगा, ये सारे मेरे रिश्तेदार हैं। एंड ही वेंट इनटू डीप डिप्रेशन। बहुत ज्यादा डिप्रेशन हो गया, अवसाद हो गया। जब डिप्रेशन में व्यक्ति जाता है, उसके दिमाग में सीरोटिन नाम का केमिकल बनता है, न्यूरोट्रांसमीटर्स होते हैं माइंड में, और वहां पर सीरोटिन बनना शुरू किया। डिप्रेशन में आदमी क्या करता है, सुसाइड भी कर लेता है। लेकिन उस समय साइकोसोमैटिक स्ट्रेस को दूर करने के लिए भगवान कृष्ण आए और उन्होंने उपदेश दिया। और वही अर्जुन कहा लास्ट में, करिष्ये वचनम तव, जो आपने कहा अब मैं वही करूंगा। डिप्रेशन सारा दूर हो गया, एक नया न्यूरोट्रांसमीटर डोपामाइन बनना शुरू होगा, और डोपामाइन ने उनको विल पावर दिया। उन्होंने कहा, करिष्ये वचनम तव, यस आई विल, आई कैन, आई विल डू। और लास्ट में कहा, फॉरगिव, मुझे माफ कर दो, जो मैं इस तरह की बातें बोल रहा था वो फॉरगिव कर दो मुझे। जो वो सब किया वो सब आपको मैं यहाँ दिखा रहा हूं। टेक केयर ऑफ योर सेल्फ, अपनी भी सुरक्षा जरूरी है। तो माय डियर स्टूडेंट, माय डियर फ्रेंड, ऑलवेज वन शुड डेवलप पॉजिटिव थिंकिंग इन द माइंड। नहीं, दिमाग क्या है, जैसा आप सोचोगे उसी तरह का केमिकल बनेगा। मन तो जाकर के मन बड़ा चंचल है, मन दौड़ता रहता है, कहीं जाके अटैच हो जाता है। इसलिए कहा गया है, संगात ध्यायते विषयान पुंसः संगस्त शुभ जायते। जब विषयों के आप ध्यान करोगे, मन वहीं जाके अटैच हो जाएगा। तो इसलिए विषयों का ध्यान न हो, नेगेटिव चीज पर आप न सोचो, हमेशा पॉजिटिविटी आएगी। नाउ द ग्रास एनरोलमेंट रेशियो इन हायर एजुकेशन ऑफ इंडिया इज वेरी पुअर, ओनली 25%। क्यों? बच्चे जाते हैं स्कूल कॉलेज में 18 से 24 साल के उम्र वाले बच्चे, और वो आगे छोड़ देते हैं। उनकी जैसी संगत होती है, उनकी जैसी सोशियो इकोनॉमिक कंडीशन होती है, कंसंट्रेशन नहीं बनता, मन बहलता है, क्या करेंगे, नौकरी तो है नहीं। अरे नौकरी चल करके आती है, यू हैव कैपेबिलिटी, यू हैव कैपेबिलिटी, नौकरी अपने आप आएगी। कितने ऐसे मेरे स्टूडेंट हैं 4-4, 5 बार कंपनियों ने उन्होंने ज्वाइन किया, हाथ में लेकर के अपॉइंटमेंट लेटर टहलते रहते हैं। डोंट थिंक, पहले अपने को कैपेबल बनाओ और आपके पास तो सर्विस चल करके आएगी। तो ग्रास एनरोलमेंट रेशियो इंडिया का जो 18 से 24 साल के बच्चों का कॉलेज में जाते हैं, यह कितना है, 25, जिसमें 19.2 मेल का है, 17 पॉइंट फीमेल का। इसका माने यह हुआ कि जो फीमेल है वो जल्दी कॉलेज जाना बंद कर देती है। ग्रास एनरोलमेंट रेशियो ऑफ अदर कंट्री, जस्ट यू सी, लुक, यूनाइटेड स्टेट का 85%, ब्राजील 50%, इवन चाइना जो हमारा पड़ोसी है, जिससे हम लड़ने की बात करते हैं उनका 50% है, हिंदुस्तान का 25%, उसका आधा। रसा जो ताल ठोक रहा है 81.8%, हम कहां पर हैं जरा आप सोचो। ये आगे हम कैसे जाएंगे जब तक अंदर एक इथॉस नहीं आएगा, यह देश नहीं जाएगा और आप भी खुशहाल नहीं हो पाओगे। इसलिए गवर्नमेंट ऑफ इंडिया ने नेशनल एजुकेशन पॉलिसी बनाया, नेशनल एजुकेशन पॉलिसी 2020, जिसमें इन्होंने उद्देश्य रखा है कि 50% GER आप अचीव करोगे बाय 2035। अभी आपके पास 13 वर्ष का समय है। इस 13 वर्ष में एक ऐसी छलांग लगाना है, मैं तो कह रहा हूं 50% के ऊपर आप जाओ। ये तो डबल है, मैं तो कह रहा हूं डबल से भी आप ऊपर छलांग लगाओ। नहीं तो हायर एजुकेशन में जब बच्चे जाएंगे ही नहीं तो कहाँ की साइंस, कहाँ का रिसर्च, कहाँ की टेक्नोलॉजी। युवा ही आगे क्रांति लाते हैं, ये बुजुर्ग क्रांति नहीं लाते। हम लोगों के दिन अब गए, अब तो रिटायर होकर घर जाने वाले हैं। तो जो युवा है क्रांति वही लाए हैं, और जो बुजुर्ग हैं वो तो जाल के पास्ट में जेलों में बैठे थे और किताब लिख रहे थे, डिस्कवरी ऑफ इंडिया। सो देयर इज अ नीड ऑफ स्किल डेवलपमेंट। और यह जो स्किल होगा वो किसके लिए होगा? एज पर कॉन्स्टिट्यूशन ऑफ इंडिया, जहां पर यह पढ़ाया जाना चाहिए सत्य को, धर्म को, शांति को, प्रेम को, अहिंसा को। यह साथ साथ में उस पढ़ाई के साथ में इन सब पर भी विचार करना चाहिए। यह इसके लिए स्किल डेवलपमेंट करना है। सो इंडियन नॉलेज सिस्टम में इंस्टीट्यूशन, इंडिया हर इंस्टीट्यूशन अब डेवलप करेगा इंडिया नॉलेज सिस्टम, जिसमें इंडियन लैंग्वेज, संस्कृत, पाली, प्रकृति, प्राकृत, क्लासिकल, ट्राइबल, इंडेंजर्ड जो विलुप्त हो रही हैं अपने देश की, इस पर भी काम करने के लिए सरकार एडवाइस दे रहा है। इंडियन आर्ट, इंडियन एंसेंट, इंडियन ट्रेडिशनल नॉलेज। छत्तीसगढ़ में भी मैंने देखा है बहुत अच्छे अच्छे मशरूम उगते हैं और लोग वहां बेचते हैं, खाते भी हैं, लेकिन उनके मेडिसिनल प्रॉपर्टी पर काम नहीं हुआ है। और इस समय आवश्यकता है मेडिसिनल प्रॉपर्टी पे काम हो, उसको हार्वेस्ट करके, कल्टीवेट करके लार्ज स्केल में फर्मेंटर में प्रोडक्ट बने, कैप्सूल के रूप में मार्केट में आए। यही सरकार ऐसा चाहती है। इंडियन आर्ट, इंडियन कल्चर एंड ट्रेडिशन ऐसा चाहती है। इसलिए सरकार कहती है कि लोकल और ओकल की बात, जो लोकल आप काम कर रहे हो उसको ओकल भी बनो। इन्हीं चंद शब्दों के साथ आप लोगों का बहुत बहुत धन्यवाद। कोई चीज मेरे से पूछनी हो आप मेरे से पूछ सकते हो। बहुत बहुत धन्यवाद सबको, और प्रोफेसर साहू को भी जो मुझे इसमें कहा था कि आपको जरूर कुछ बातें अपनी शेयर करनी है, तो मैंने शेयर किया। बहुत बहुत धन्यवाद प्रोफेसर साहू। Now over to the organizer of this event.
धन्यवाद सर।
सर बहुत बहुत धन्यवाद इतने अच्छे लेक्चर के लिए, और बहुत शॉर्ट नोटिस में ही आप मेरा रिक्वेस्ट एक्सेप्ट कर लिए थे, उसके लिए मैं भी आभारी हूँ सर। और लेक्चर बहुत अच्छा था। बच्चे किस तरह से रिस्पॉन्ड करेंगे ये तो इसलिए थोड़ा सा डिफिकल्ट होगा कि ये बड़ा ऑडिटोरियम है सर, वहाँ ये बड़े स्क्रीन में प्रेजेंटेशन चल रहा था, एंड
अच्छा
ऑडिटोरियम सर आउटसाइड इन दिस कंट्रोल रूम। सो अगर उनकी कुछ क्वेरी भी होगी तो वो आप तक शायद नहीं पहुंचा पाएंगे उन लोग। बस यस, सारे स्टूडेंट अगर चाहते हैं कुछ क्वेरी है तो मुझ तक उसको दे दें, तो मैं दुबे सर से जरूर रिक्वेस्ट करूंगा उस क्वेरी को क्लेरिफाई करने के लिए। और हमारे वाइस चांसलर साहब हमारे बीच उपस्थित हो चुके हैं, शायद वो भी दुबे सर को कुछ बोलना चाह रहे हैं। सर प्लीज सर, प्लीज।
बहुत अच्छा लगा प्रोफेसर दुबे का व्याख्यान, और
बहुत धन्यवाद।
सरल शब्दों में हर किसी को जो कि विज्ञान के नहीं है उनको भी ऐसी जानकारियां मिलती रही, और बहुत व्यवस्थित ढंग से आपने सिलसिलेवार बातें की हमारे ज्ञान परंपरा की, और आज हम कहाँ तक पहुंचे हैं और क्या हमारी स्थिति रही है भारत की। तो बहुत अच्छा लग रहा है। मैं लगातार काम के साथ साथ भी आपको सुन रहा था। और
बहुत बहुत धन्यवाद।
आपके भी पुनः इसलिए उपस्थित हूँ कि आपका आभार व्यक्त कर दूं कि आप के प्रति हम आभारी हैं कि आपने हमें समय दिया, हमारे विद्यार्थियों को नई नई जानकारी और बहुत ही विज्ञान के प्रति रुचि जागृत करने के लिए आपने प्रेरित किया। बहुत अच्छा लगा। और वस्तुतः जो अभी प्रोफेसर साहू ने जो कहा कि हमारे यहाँ पंडित दीनदयाल उपाध्याय ऑडिटोरियम है जिसमें यह कार्यक्रम संपादित हो रहा है, 1500 की कैपेसिटी वाला बहुत बढ़िया हमारा ऑडिटोरियम है। और वहीं हमने ये व्यवस्था कर रखी है बड़े स्क्रीन में कि जिससे आपका व्याख्यान सब लोग वहाँ सुन रहे थे, हमारे शिक्षक, हमारे विद्यार्थी और जनता सब सुन रहे हैं। और साथ ही जो डिस्प्ले किया गया है उसी ऑडिटोरियम में किया गया है। इसलिए डॉक्टर साहू ने जरूर ये कहा कि अगर बच्चों की कुछ क्वेरी होगी या कुछ जिज्ञासा होगी तो वहाँ कहेंगे तो उनके माध्यम से हो जाएगा। लेकिन ये बहुत लोगों के लिए अभी आपका व्याख्यान उपलब्ध रहा, उनसे जुड़े रहे और हम सब बहुत लाभान्वित हुए। मुझे तो बहुत अच्छा लग रहा था, मैं लगातार देखता रहा, सुनता रहा आपको। पुनः आपके प्रति मैं
बहुत बहुत धन्यवाद सर, बहुत बहुत धन्यवाद। हाँ,
Thank you once again, sir, to our Vice Chancellor, sir, at the same time, Professor R.C. Dubey, sir, for delivering such a nice and wonderful lecture. Thank you, sir, once again. So,
Thank
friends,
you,
now
Professor.
it's time to have little knowledge about the our computer science department. What those people are doing in the department in relation to the progression of science, its dissemination, and all those activities. So I would like to request Professor Sanjay Kumar sir, head of the department, Computer Science Department of Pandit Ravi Shankar Shukla University, Raipur. प्लीज सर आइए और अपना छोटा सा प्रेजेंटेशन 10 से 15 मिनट का है, उसमें बताइए कि आपके डिपार्टमेंट में किस किस तरह की एक्टिविटीज हो रही हैं और कैसे आपका डिपार्टमेंट का ये सब काम सोसाइटी और हमारे जो विद्यार्थी हैं स्कूल के, कॉलेजेस के, उनको उनके लिए कैसे हेल्पफुल है, कैसे उनको और आप असिस्ट कर सकते हैं इन देयर प्रोग्रेशन। प्लीज सर आइए।
all these